go. Here we 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 go.
Hello, and welcome to Containers from the Couch, our weekly show where we talk about all things containers and AWS. And today is a really cool show because we're talking about Kubernetes, the EKS with Kubernetes, and GuardDuty. So if you're looking at security and Kubernetes and AWS, we got a show just for you because we're going to cover all of that. So with me today is Jeremy on this. I always forget because it's mirrored. Hey, Jeremy, how's it going?
I'm good. Thanks, Justin.
Yeah. Tell us a little about what we're doing today and who's with us.
Yeah. So today we're going to have a look at GuardDuty Kubernetes audit log integration and where it fits in your overall security toolkit. As Justin said, my name is Jeremy Cowan. I'm a developer advocate at AWS. And with me today are two special guests, Amit and Zeke. And I was wondering if each of you could tell us a little about yourself and how you came to work for the GuardDuty team.
Yeah, sounds good. Thanks, Jeremy. So I can get us going. So I've been on the GuardDuty team now for almost 4 years. I lead product management for GuardDuty. We're part of the broader external security service organization here at AWS. So other services under the same org are Security Hub, Inspector, Detective, Macy, and then GuardDuty, which is the team we're from. I joined, I've always been passionate about the security space. I have some background in it as well, and knew that AWS is a place where I can have really, really broad impact on the security of a lot of customers. So that led me to be excited to join the team here 4 years ago.
Great. Zeke, how about you?
Yeah, I'm a principal security engineer in GuardDuty. I have been in GuardDuty for 4 years as well. My primary job is to continuously improve the quality of detections and detection capability that GuardDuty offers. I also research into expanding GuardDuty into other areas and new areas to provide further or more value to our customers. One of the areas that I've been focusing on is container security and container threat detection for last 1 year or so, and GuardDuty for Kubernetes audit logs is one of the outcomes of that work. What excited me about GuardDuty and why I joined GuardDuty, it was basically like it was at that time it was the only threat detection service in AWS, and I thought that it would be so cool to work on threat detection in AWS with all the data and all the information that we have available. So that's why I joined GuardDuty, and we have been expanding GuardDuty since then.
And for those folks who may be listening who are interested in working for AWS in the future and perhaps working on the GuardDuty team, what did you do before joining the GuardDuty team? What was your background, and did it involve security? It seems like it did, but curious what backgrounds both of you had.
Yeah, so my background, I'm originally from Israel. That's where I lived before coming to the US. And in Israel, I was working on mentioned cybersecurity or cyber-related fields in the national intelligence community. So sort of from a different angle, but interesting one to learn about the security space, cybersecurity space, and that sort of gave me, I guess, the sort of domain expertise that allowed me to come here and join AWS. Moved to the US and completed my MBA. So sort of coupled with that business education and combined that led me to the path for PM role here at Amazon and specifically the GuardDuty team.
Nice. How about you, Zeke?
Yeah. So I have been working as a security engineer for 20 years now, and 10 of those years have been in Amazon. Before joining GuardDuty, I was an application security engineer um, with the Amazon's retail side, where I was responsible for securing the retail um, application and the whole infrastructure which supports the retail website of Amazon. And before that, I worked for several years in HSBC Bank, again as a security engineer, where I was responsible for securing their um, internet applications and the related infrastructure.
Nice. And uh, for those folks who may not be familiar with the guard duty service, can you tell us a little about that service and the problems it was designed to solve?
Yeah. So GuardDuty is a threat detection service. Um, it listens to various data sources or event sources related to your AWS accounts, and it monitors those data events and data logs, and based on that, it tries to detect threats and attacks against your AWS accounts. Um, One of the good things about GuardDuty is that it is one click, so you can enable it with just one click. It does not require any setup that you need to do as a customer. So as soon as you enable GuardDuty, it starts. Currently, it starts um, in the background listening to 5 different log sources related to your AWS account. These are VPC flow logs, DNS logs, CloudTrail logs, S3 data plane logs, and the newest one is the Kubernetes audit logs. So if you want, I can talk a little bit more about the details of these logs and what type of threats these different types of logs detect.
Yeah, it'd be great to learn a little about how it detects threats in your account. As you mentioned, it looks at various logs, but how does it distinguish threats from normal behavior?
Right. Um, so the first one is VPC flow logs. So VPC flow logs, they basically emit events related to network connections, ingress and egress network connections from your EC2 instances. So they allow us to observe and monitor the network activity of your EC2 instances. So we are able to detect if your EC2 instance is going out and connecting to a malware CNC server or a Bitcoin mining server. So this is like one type of alert that we have, which is based on threat intelligence. So if your EC2 instance is interacting with some endpoints which are on our threat intelligence, we create an alert to alert you, because in that case, it's highly likely that the EC2 instance might be compromised. Other than that, we also use flow logs to profile the activity profile of your EC2 instance, like what type of connections your EC2 instances normally make, and then we use that profile or the learning that we have gathered about your EC2 instance to detect anomalies. So if your EC2 instance makes a connection which is anomalous compared to its historical profile, we'll create an alert for you.
Can I ask a
This,
question about
yeah.
the networking activity? So when you run Kubernetes, it's not uncommon for you to run multiple pods on an instance, and so when GuardDuty looks for threats, is it able to identify the pod that may be compromised, or does it notify you of the instance that the pod is running on may be
So
compromised?
it depends on the type of audit source or data source that we have used for this detection, for a
I see.
specific detection. So if the detection is based on flow logs, then at this moment we are not able to identify the pod or the container. We'll just identify the EC2 instance. If the detection is based on Kubernetes audit logs, then yes, we'll identify all the details related to the pod, or the workload resource, and all the details related to your EKS cluster.
Fantastic. So you were saying that the flow logs, the VPC flow logs, serve as an event source, as do the Kubernetes auto logs. What are a couple of the other event sources?
Yeah. So the other, the second event source that we can talk about, the DNS logs. It's also related to the EC2 instance. It basically gives us events about the DNS lookups made by your EC2 instance. So again, it also allows us to identify based on domain name based IOCs if your instance is trying to connect to a CNC server or a Bitcoin mining server or drop point and alert you on those things. It also allows us to identify, like, if your EC2 instance is looking up DGA domains, which is an indication, which is usually an indication that your EC2 instance is compromised or infected with malware. Another important thing which it allows us to detect is DNS exfiltration, which is a very common technique for exfiltering data out of EC2 instances. The third one is CloudTrail logs. So CloudTrail logs are basically the application logs or API logs for all of the AWS API, right? So they allow us to monitor activity of various IAM users and IAM roles in your account, what type of API activity they are performing, and so on. So if for example your credentials related to your IAM user or IAM role is compromised, then based on that CloudTrail activity monitoring, we'll be able to identify that the attacker activity might be suspicious and will be able to alert you.
I see.
Yeah.
So, oh, sorry, Amit, did you have other things you wanted to add?
Yeah, I was just gonna add in regards to, so what Zeke was talking about, the flow log, the DNS, the CloudTrail, both the control plane and the S3 data plane. And then on each of those, we have different detection capabilities and analytics. One of the things that works well is that it's very easy to enable GuardDuty. It's quite literally a single click, and there's very little configuration to ensure continuous coverage across your entire environment. So when I say single click, it can be a single click at the account level if you're managing an individual account, and we have customers that operate in organizations with thousands of accounts, and it can still be enabled very, very easily. And then behind the scenes, as Zeke mentioned, we start consuming the logs on your behalf, the different log sources, so you don't have to go and actually enable any of the logging and incur the related logging costs and storage costs for these logs and delivery, etc. It all happens behind the scenes. And another thing it means is that now you're continuously covered across your infrastructure, also for any new resource that pops up. So we started monitoring your flow logs, and tomorrow, you set up another VPC, new instances, automatically GuardDuty will start monitoring them. As well as at the organization level, if you set up a new account, you can set it so that GuardDuty will be automatically deployed on that account, and again, start monitoring all the resources in it. So we made it really easy to set up and turn on and have continuous coverage. And then we're continuing to iterate on the security value and the detections for each of these existing log sources. A lot of focus on building the data science team here and more advanced machine learning capabilities for anomaly detection. Currently, mainly on the CloudTrail control plane side, but we're looking to expand that. And more focus also on leveraging our own visibility as AWS to provide more and more accurate threat intelligence for these environments. So yeah, exciting, and a lot of work going on the existing log sources. And then the other part of it is also listening to customers that are telling us, okay, we like what you're doing with GuardDuty. We already operationalized it, set it up to connect to our SIM solutions, ticketing, alerting, etc., and trusted detections that we output. And then they're asking us to go, okay, now we want you to cover additional AWS services. What can GuardDuty do for RDS, for Lambda, for containers? And that's what led us here to listening to that customer feedback and expand coverage to the Kubernetes audit logs at the start.
That's great. Yeah. So you anticipated my next question. The GuardDuty integration with the Kubernetes audit logs have been in the market for roughly like 3 or 4 months, and I was curious like what the impetus was for adding Kubernetes as an event source. You mentioned that it's largely driven by customer demand. And so this is the culmination of those efforts, I assume. What other things were motivating you besides customers? Was this a space that you had always intended to move into?
Yeah, so I can start with a few things, and then with Zeke, I'm happy for you to add on more the security research side that you did on this, because that's one of the reasons is, with Zeke and the team here did a lot of research to actually, we want to first make sure that there's an actual threat vector here and a risk to customers in real world scenarios. So that's one thing. We identified that there's real risk here, and with Zeke, I'm sure we'll add about that. But then, yeah, as you mentioned, listening to customers, container services deployment, specifically, EKS, ECS, non-managed Kubernetes across the board is growing, and growth is accelerating. More and more compute using these solutions, and in the threat detection service for AWS, we need to go there and make sure we give customers coverage to where they deploy their workloads or sensitive workloads, production workloads, etc. So yeah, it's definitely going where what we heard from customers. And then I'd say another angle for it is also that we heard from customers that specifically when dealing with containers, there's an added layer of complexity exactly for that, making sure it's on everywhere and covers all. Because if EC2 instances can pop up and down, then when you're talking about containers, it's the problem is multiplied, or tenfold or thousandfold. So having a solution like GuardDuty that can have that broad coverage today, all clusters, all pods, all containers going forward, anyone that pops up anywhere in your universe of containers will automatically be covered if you have it on for the account or organization, I think solved a real big customer pain point, and that drove us as well.
Great. And can you give us a sampling of the sorts of threats that can be detected by GuardDuty Cal? The Kubernetes
Yeah,
integration?
definitely. Yeah, we can talk about that, but before that, I would like to expand on Amit's discussion about the rationale for adding Cal support. Yeah. From the technical perspective. When we do the security value analysis of Kubernetes audit logs, we figured out that these logs are extremely valuable when it comes to threat detection on Kubernetes, right? And there are some very specific reasons. I mean, the first and foremost, the biggest reason is that the Kubernetes API and Kubernetes in general, it adds an abstraction layer on top of your compute resources. And you don't have any visibility into that except abstraction layer other than visibility through the audit logs, right? So for example, an attacker can compromise your credentials, and then they can use your Kubernetes API to spawn hundreds or thousands of different pods on your Kubernetes cluster, right? If we are monitoring just CloudTrail logs, we won't get any signals in CloudTrail logs. Probably we might get signals in runtime logs like the flow logs or the DNS logs, but those signals would be delayed a little bit. Those would be post-exploit, at the post-exploitation stage where they might have installed a malware, and that malware is trying to reach out to a CNC server. But what's good about audit logs is that it's a point of entry. I mean, this is the first point, and then you can immediately identify and you can get very quick signals about the suspicious activity, and you are able to alert much more quickly, um, alert the customers much more quickly. That's one thing. The other thing is that Kubernetes is complex, and it's extremely flexible and feature rich, and because of that, it also has a pretty significant attack surface, and sometimes, unfortunately, customers they make configuration mistakes on Kubernetes, which make their clusters vulnerable to attack. um, so audit logs are really good at identifying those configuration mistakes and alerting the customers right away. And even if if you are not able to identify the configuration mistake, when the attack happens, if a successful compromise occurs, audit logs, as I said earlier, they would provide you a very quick signals, and you'll be able to alert the customers right away and potentially avoid extensive damage. Um, Another point that I have noticed is that in Kubernetes ecosystem, in container ecosystem in general, people tend to deploy lots of open source software, and we have seen customers deploying um, you know um, Kubernetes applications using YAML files, YAML config files from GitHub, and they usually don't know what's inside. Like, they don't have intimate knowledge about what's inside those YAML files. And we have seen examples of very popular applications which in their YAML files they had some vulnerable configurations, right? So because of that, it- kind of a common practice, unfortunately, um, you know people can unknowingly make their clusters vulnerable. So again, if you are monitoring Kubernetes audit logs, um, there is an advantage that there will be an early detection and containment of damage.
Great. And so, could you describe a few of the threats that GuardDuty can detect?
Yeah. So currently, we have the initial batch of detections that we have launched. Uh, they can be divided into three different categories. The first category is the policy findings, which detect common configuration mistakes that lead to that make a cluster vulnerable, right? Um, and as soon as we detect those configurations happening, we alert the customers. The second type is the threat intel based detections, which which basically detect if there is a known bad IP address successfully executing APIs against your Kubernetes cluster, then we alert you. So, for example, if there's an IP address on our threat intel list, we are going to generate a malicious IP caller finding for you. It may be an IP address on the customer's custom threat list that they have uploaded and they manage themselves.
Mhm.
We are going to generate a malicious IP caller dot custom finding, for example. It may be an IP address of a Tor exit node. So if the attacker is trying to come in through Tor network and so on. So these are the like threat intel based findings. This, which is the second category. The third category is and which and this is the third category. We are still expanding that. We are adding more and more detection, and we'll be adding more and more sophisticated detections to that category. So the third category tries to detect suspicious activity potentially from by an attacker. It
Mhm.
tries to detect typical activity which attackers perform once they have compromised a Kubernetes credential. Um, you know, there will be findings in that category which will try to detect um, anomalous behavior that attacker might produce. So, so yeah.
I'll add on that last point that
Yeah.
um, Yeah, anomalies in security is it's a difficult challenge we've been investing a lot in because in the end of the day, attackers use the same APIs and do configuration changes that are also part of benign day-to-day activity of cluster operators and just people working on AWS. So we invest a lot in that struggle and being able to discern, not just say this is anomalous for this environment, but this is anomalous and highly suspicious from a security perspective. So we won't necessarily look at all the APIs, or we'll look for certain combinations or features that we know that if they're unusual, it's more indicative of malicious activity. And that's a big focus. How do we get our detections in general, specifically the ML-based anomaly ones, more and more accurate, lower noise, higher fidelity? And it's also as always, when we're also super interested to hear customer feedback. A lot of our tuning of detections that we're working on was based on customer feedback, as well as new detections we introduced based on customer feedback. So if anyone out there, thinks of or knows of container Kubernetes related attack vector you feel GuardDuty isn't covering, bring it to us, and Zeke will immediately take it and start investigating, and hopefully it'll turn into a new GuardDuty capability.
That's great.
Yeah.
We're like halfway through the show. Do we have a demo? Do we want to show off some of the capabilities as we're answering some of the questions, or is there a couple things that I love seeing it in action too. Great information so far.
Yeah, as do I. I was going to ask about integration with other AWS security services. AWS has a whole slew of services to look at a variety of different things. And perhaps as part of your demonstration, you could show or explain how GuardDuty works with these other services.
Yeah, definitely. I can start the demo. I can start with showing what detections we have, just to give people a flavor of what we have, and then I can show in the AWS GuardDuty console how different types of findings look like, and what is the information available in those findings, and how would you interpret those findings.
Yeah, that'd be great.
Yeah. So I'm sharing my screen.
Yeah, I can pull it in.
Let me know. Yeah.
I see us.
Can you see my Chrome web page?
Yeah, we see the StreamYard window.
You only see the StreamYard window.
Yep.
Okay.
Can
you see the other window now?
Different browser window.
Nothing yet. Hold on.
Nothing.
You might have to fully stop and then restart it.
Yeah, I can. As Zeke pulls it up, I can sort of start talking to the point of the integrations.
Mm-hmm.
Zeke will show part of what it'll show will be the GuardDuty Console, which is a great place for a lot of customers to consume GuardDuty alerts and do that initial triage. And I think there's some good ways we parse the finding fields, and you'll see that in a moment. We highly recommend it. That's not all customers do. We know a lot of customers integrate their GuardDuty alerts directly into their security SIM solutions or ticketing, alerting, Jira, ServiceNow, PagerDuty, Slack. But at the very least, we recommend that across customers, there's at least some level of push mechanism for GuardDuty. So it's not only consumed by going into the console, and it can be as simple as setting up an event bridge rule with an SNS email and make sure you get push notifications for GuardDuty findings, or you can set it for high severity findings, which is, you can see on our documentation how to do that. Just to make sure that when something does happen, if you're not sort of monitoring it daily or pushing the findings out already, then you see it you see the findings. So yeah, that I think is important across all customers to make sure happens. We'll see for you. You good to go?
Can you see my screen now?
Yeah, we see
The
the
Q.
key findings
Yep.
window.
Right. Yeah. So this is the main page where the in GuardDuty documentation, which lists the Kubernetes findings. Right. So as I mentioned that we have three categories of findings. The first category is the policy findings. So here we have four policy findings. So some of the obvious ones, like these are some of the obvious mistakes that we have seen customers making. So for example, anonymous access granted. When we detect that a customer is granting anonymous user in Kubernetes access to their APIs, um, then we create this alert. So anonymous user basically means an unauthenticated access to Kubernetes API. So that has been a root cause of many some of the known attacks that we have detected. And then, because of this finding, you are readily alerted if somebody has tried to create a configuration where they are allowing unauthenticated access to the Kubernetes API server.
I'll,
Yeah.
I'll
So
I'll just
these.
add. Sorry, I'll add here quickly. I mentioned the whole integrating GuardDuty was the ticketing alerting systems. One step further would be to actually integrate it into taking action or automated action. And it may not be the right fit for all alert types across all environments. But these type of alerts that are pretty clear, there's no reason for, to have unauthenticated access to your Kubernetes clusters. We see customers use these type of alerts to then, again, through EventBridge, trigger a Lambda function to reconfigure the cluster and make sure it's not accessible. So yeah, these are the type of things you definitely, that's the end goal, right? You want to action on these alerts and make sure you're more secure. Sorry, Wasif, yeah, please continue.
Yeah. And as I said, the second category is the threat intel based category, where we primarily have um, three different types of findings. The one is malicious IP caller, the finding names which are ending in this malicious IP caller term. Um, this basically means that the IP address, the source IP address, which has successfully executed an API on your Kubernetes cluster, is in our threat intel, and we identify that IP address as a known bad IP address. Um, yeah, and then similar to that, we have malicious IP caller dot custom findings, which again detect that some sort of a known bad IP address is successfully executing APIs on your Kubernetes clusters, but that IP address is not on our threat intel list. It is basically on the customer threat intel list, which customers manage and maintain. Yeah.
So how would this appear in the GuardDuty console? Could you show us a little of that?
How the finding appears?
Yeah, how the findings appear.
All right. Yeah. Can you see AWS console?
Mm-hmm. Yeah.
Yeah. So if I go to GuardDuty, uh, so this is the main page of GuardDuty where all different types of findings, not just Kubernetes findings, are showing. But what I can do, I can include a filter if I just want to show or view uh, just Kubernetes findings. So what I'm going to use, I'm going to use resource type as the filter, and I'm going to specify EKS cluster as the resource type. So as soon as I hit apply, now I can only see, now I am only viewing the Kubernetes audit logs findings here. So yeah, coincidentally, the first one is actually malicious IP caller custom, right? So this first page it's the summary of the findings. So if you want to see the details of a specific finding, just click on it. So if I click on this one, So I can see the details of this finding here. Yeah. So all the details. Um, uh, the most one of the most important section in any guard duty finding is the resources affected, which shows all the resources involved in that alert. So in this case, you have your EKS cluster. So we will provide all the details about that EKS cluster, which has been impacted or which is related to this finding. And then you have other resources as well. For example, uh, any Kubernetes workload, which is related to this finding. Uh, Users are also considered a resource in guard duty, because users is a resource which could be compromised, meaning that the credential of a user is compromised. So you have user details as well here. So you have Kubernetes specific user details, but in case of EKS, a Kubernetes user is usually mapped to an IAM user or IAM role. So
Mhm.
because of that, you also have IAM related AWS IAM related details here as well. Because this user in this case, for example, the Kubernetes username is admin, but it is actually mapped to a IAM role, and the name of that role is Kubernetes ops role, right? So you can see the user type is role, so that's why I'm saying it's a role.
I see.
Um, so 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 this finding may indicate that this user is somehow compromised, which basically typically means that the credentials of that user of this user is compromised. So in this case, because it's an IAM role, credentials of that role may be compromised, right? So as a receiver of that finding, you need to figure out what happened to this role, who assumed this role and then called this API, just to investigate further, whether it's a true positive, and then what's happening in your environment. So one thing I would like to highlight here is that we have another service called Amazon Detective. So Amazon Detective, it can be very useful in further analyzing a compromised IAM user or IAM role, like in this case. In every guard duty finding, when you go to the console, you'll get this link here, investigate
Mhm.
with detective. So you can click on this link, and then you can click on the related role. So this is the role which is associated with this. If we are considering it's a compromised role, this is the compromised role. So if I click on this should take me to Amazon Detective. And then from there, I should be able to figure out who assumed this role in this time frame, which will provide me more investigative information. So here, this is the overview of this role. I can go to resource interaction. And in resource interaction, I can see role assumption activity during the scope time. So here I can see that, you know, this role was assumed by an EC2 instance, right? So,
Mhm.
this is the actual origin, original credential which assumed this role, right? So I can see that this is test EC2 is the name of the EC2 role, or EC2 instance profile. I know this is EC2 instance profile because of the format of uh, this original credential. uh, because after colon you have I dash something, which indicates um, it's an ID of an instance, EC2 instance. So now I know that this EC2 instance was used to assume this role. So I can go to that EC2 instance, I can log into that EC2 instance and further investigate what happened on that EC2 instance.
I see. So is it possible to use this to see whether the pod running on that instance is assuming the role or the instance profile assigned to that instance? It seems like that might be in play here. Or perhaps the pod is assigned a direct role through URSA. I don't know whether that would be detected through here, but it seems like you might be able to detect whether a pod is able to query IMDS, the instance metadata service, and if so, then disable IMDS or configure IMDS to use version 2 with a hop count configure it to use IMDS v2 with a hop count of 1 so that pods aren't allowed to inherit the role assigned to the instance. It seems like you'd be able to detect those sorts of things through here, at least indirectly.
Yeah, there are multiple possibilities. At this point, the way I'm showing here, at this point, I know that a role is compromised, and I know that this role was assumed by an EC2 instance using an EC2 instance credential, and potentially the attacker got access to that EC2 instance. Now it depends on what was the actual attack vector. It depends on the nature of that EC2 instance. What is this EC2 instance? So if that EC2 instance is a worker node, then your hypotheses may be correct. Like it may be just a pod which got compromised, and then that pod is able to somehow gain access to the EC2 credentials. If that EC2 instance is not a worker node, but it may be an operator node. So in that case, I mean, there may be other attack vector. It may be just an SSH key compromised or anything like that.
I had another quick question here. So I noticed that you're assigning a severity to each of these threats. Can you talk a little about how you assign a severity to a threat? Like, how do you know a threat is like low, medium, or high?
So the severity is based on the activity, right? So it is based on the inherent risk of the activity which has been performed by the attacker, and the activity on basis of which we have made this detection. So in this case, if you see, it's medium, so it's not high. And if you see the first part of the finding, it's called discovery. So it identifies the tactic which is involved in this alert. So in this case, we found out we detected this based on a Kubernetes API, which is associated to discovery tactic in general. So such as list pods, so which is a discovery tactic.
Right.
So it's not a mutating activity, and that's why we have classified it as medium. But if you see the other finding here, the second one on the list, which is credential access, it's again the same malicious IP caller dot custom, but the tactic here is credential access, which is more serious tactic, or which is more serious impact, right? So that's why we have labeled it as high severity. And why it is credential access? Because of the API, um, the API call involved in this detections, which you can
Oh,
see here. So if you go to the action section, you can see the request URI, which is the Kubernetes request URI. So you can see that in this case, it is secrets, right? So the attacker is able to download all the secrets of your Kubernetes cluster in this hypothetical um, detection. So that's why we have classified as high severity.
yeah, I'll just add if you saw what Zeke mentioned the tactics. So we're more and more in guard duty alerts in general, and here specifically trying to map the alerts to the MITRE attack matrix tactic, which we know is helpful for customers to identify the attack stage with the common terminology. I want to say there's that the high severity, so the high severity would be more obtrusive. So we look also at the specific APIs. Wasik showed some of the details we had. So a lot of them are details that can be found in the event itself. We also do an added layer of decoration with tags. So if you're using tags for your EKS clusters, we'll decorate the finding with that as well. And we know that can often also be very useful for a security analyst or operator when doing that initial triage investigation. So that's there as well.
Awesome. And with the little time that we have left, I was wondering if you can give us insights into what's next for GuardDuty Cal. You mentioned that you're looking at incorporating ML in the future. Can you elaborate a little further about that?
Yeah, I can take this one. So I think GuardDuty Cal is as GuardDuty, the rest of GuardDuty. Our North Star is the security value, differentiating security value. How can we help better protect customers? And that means more and more accurate threat detection capabilities, analytics, threat intelligence. So we're doubling down on all of those. We're listening to customer feedback that's coming in. We were able to work with some customers already through these detections and help them investigate and prevent potential security incidents related to their clusters. So that we're happy for that, but we're also listening to feedback on how we can tune the alerts better. So we're going to improve the existing ones, and then as you mentioned, we're also working on newer ones, and was a focus on some more advanced machine learning capabilities to detect anomalies. We found that just detecting an anomaly, especially in a Kubernetes environment, of something that, just maintaining a state and seeing, oh, this hasn't happened before, will be very noisy because the environments are very dynamic, and just because something hasn't happened in the past 30, 45, 60 days doesn't mean it's really unexpected for the environment. Mm-hmm. And that's where ML comes in. It worked well for us with the CloudTrail control plane, where as opposed to that state-based anomaly approach, the ML models are able to say not just this hasn't happened in the environment before, but this wasn't expected to happen, even if maybe something similar happened. Or in another case would be, this never happened, but it was expected to happen. And that's sort of where the magic of ML comes in, and is proven to work well with CloudTrail. And we're very optimistic with what we think we can do for the Kubernetes audit logs as well, to detect those interesting attack vectors that maybe the IOC's threat intel won't catch.
And what do you think is one thing you want folks to take away from today's session?
Yeah. Before that, I would like to add about our ML-based detections.
Of course.
So one point I would like to highlight is that those upcoming ML-based detections, they will allow us to detect suspicious attacker activity on the cluster, and they will allow us to detect things like anomalous container launch, right? Which is the most common thing which attackers usually do when they have compromised your Kubernetes cluster. So it's going to be, I would say it's going to add lots of value. As far as one thing that I would like to say that people can take away is I would like to reiterate that Kubernetes is complex, and it has an attack surface, and although it has revolutionized application deployment at a scale, it has also introduced complexity and attack surface with it. And Kubernetes audit logs, it's a great way for early detection of threats and attacks against Kubernetes clusters. And based on our experience with CloudTrail, it's very similar to CloudTrail, and we have wealth of experience on working on CloudTrail. We'll be applying. We have applied, and we'll continue to apply the same experience on Kubernetes audit logs. So we'll be able to provide lots of value in terms of early detection based on Kubernetes audit logs.
Yeah, I'll just add to that and then say my maybe one takeaway.
Sure.
Kubernetes is complex for developers working on Kubernetes. So yeah, it's maybe even more complex for security teams and security analysts that now have to start dealing with Kubernetes related threats. I think it's a great place for collaboration between security teams and developers and cluster operators to learn these findings and to understand their meaning and help security teams also get to a point where they understand the Kubernetes environment well enough to investigate and respond to these alerts. Yeah, we're seeing challenges there, as Zeke mentioned, the complexity, but it's super important for as security teams across organizations to learn these spaces. The one takeaway, I guess, yeah, to turn this on. If you're using if you're not using GuardDuty, turn on GuardDuty, and this will be automatically on the Kubernetes protection. If you're already using GuardDuty on your account or organization, then it's an opt-in because there's some added cost. So we made it an opt-in for existing customers. But for all customers, if it's the first time you turn on GuardDuty, if you're existing and you opt in, you'll get a 30-day free trial. We priced it with the intent in mind to make it an easy choice for you to go all in. So hopefully that meets customer expectations on that, and that we provide a good security value to meet that. So yeah, the one takeaway is yeah, if turn on GuardDuty. If it's not on, if GuardDuty is on, opt into the Kubernetes audit logs. Get that during 30-day free trial. The cost estimation post free trial. Make sure it meets your expectations. If not, let us know, and operationalize it. I mentioned it earlier, but it's not enough to turn it on. Make sure that unless you go into the console every day or have it constantly refreshing, at least for the high severity alert, set up some push notification, event bridge, SNS, email, at the very least, Slack integrations, to make sure that the alert doesn't just sit there in the console for days without anyone noticing it. So yeah, and one last thing, I promise.
Okay.
Feedback. Yeah, bring us feedback. We always welcome it and are interested to hear and continue to iterate on your behalf. So feedback.
And Amit, where should they send that feedback?
So there's the AWS forum. It can be through support. It can be if you're working with account teams and SAs, etc. Then through them. And yeah, and all those channels, know how to channel it back to us. Can even be on social media, on Twitter, and then we have teams that listen to those and make sure to channel it to the right team. So whatever way possible, just to help us get better and help you.
Great. Well, thank you, Amit and Zeke, for participating in today's episode of Containers from the Couch. I really appreciate it. Justin, thank you for hosting. And with that, you can take us out.
Yeah, I just want to say real quick, if anyone hasn't subscribed to the channel, we have a ton of content that's been pushing out over the last couple weeks. This week is actually really busy. We got streams every day. We got some pre-recorded content, and we got some more shorts coming. So go ahead, check it out, containersfromthecouch.com. Subscribe there. We're also doing this on Twitch, obviously. So thank you, everyone that's been coming, and hope to see you. I'll be back tomorrow. We're talking about Helm charts with EKS. So hopefully see you, everyone else, soon.
All right. Thanks a lot.
Everyone.
Bye.
Thank you.